Under the Mobil Serv offer, this video is a piece of the leak detection on-the-job training curriculum that will enable you to convert customer needs and opportunities around leak control into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT for leak detection. After viewing it, you should job shadow another competent person completing an oil leakage control study, and then have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Eric, a field engineer with ExxonMobil, has been working with this plant on a number of Mobil planned engineering service projects. Jeff, his contact at the plant, tells Eric that he'd like them to focus on an oil leakage control study. The plant's oil consumption has become excessive over the last few months. Eric works with Jeff to understand the impacts of this leakage so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. Eric and Jeff had been mutually planning a leak detection study. Now, this was their opportunity. To help bring solutions and value to his customer, Eric must be an excellent detective and must collect the data needed to help determine the root cause of the increased oil consumption. Before meeting Jeff again for the leakage study, Eric gathered consumption tracking information from the plant so he could identify high users for inspection. He looked at increases in trends to show when new leaks developed. He also calculated the lubricant or hydraulic fluid index, or HFI. You determine this index by dividing the estimated annual oil consumption by the reservoir size. Systems with the highest HFI may prove to be the ones with good potential for investigation. Achieving an HFI under 1 is a good goal. Eric wanted to get a reliable estimate of current consumption rates for each system. Some of these were metered measurements, but in some cases Eric could only get oiler or operator feedback. Eric knew that he must find answers to 3 critical questions. Where to look, by identifying the high consumers as well as potential leakage points. When to look, by identifying when new, significant leaks develop. In addition, he may need to inspect the equipment when it is running as well as when it is shut down to be able to track down the leakage source. When to stop looking, by comparing the sum of leaks identified to the known consumption rate. Eric also went over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also read through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including PPE. Then, Eric prepared and reviewed his toolkit for the site visit. Inspection checklist sheets. Ultraviolet UV dye. He will use this in his leakage control studies to show his customer exact points of leakage and to allow him to better estimate leakage quantities. Digital camera and thermographic camera, oil sample kit, and lubricant system schematics or piping diagrams. On the morning of the site visit, Eric and Jeff first review their goals for the visit. Eric goes over his safety plan, and together they review the personal protective equipment they'll need. Hard hat, safety glasses and hearing protection, cut-resistant gloves, visibility vest, and anti-slip steel-toe boots.
I think that should do it. Let's go to it. Let's get her done.
Eric and Jeff begin with a general survey of the lubrication system. Eric refers to equipment drawings and schematics to help him understand locations where potential leakage may take place. Here in the basement, they first take a quick look into the drain. They might see evidence of leaking oil. This might also provide a means to trace any leakage to its source. Later, they'll come back during their UV leak test to take another look at this drain. They check the oil flow meters and record their findings. Eric also checks flow against time. Next, they look up, where there is some evidence of leakage. They will repeat this later with UV light. In preparation for the leak survey using UV dye, Eric adds UV dye to the reservoir 1 to 24 hours prior to the inspection. He adds the dye through the fill cap or other suitable opening at a specified rate using a dye compatible with the lubricant and at a dosage rate per the dye manufacturer's instructions. The machine should be run normally while the dye circulates to allow leaks to bloom. It is not sufficient merely to have the lubricant pumps on. All points need to be actuated or cycled repeatedly, as they would with normal operation, to see leaks when the lubricant is under pressure. Eric puts on his enhancing glasses and readies his UV inspection light. He and Jeff return to the drain, since that is a likely place where leaking oil could collect in large accumulations and help them trace the source of the leaks. Again, they check piping with the special UV light. Eric now combines his first walk-around inspection findings with the UV inspection findings to help trace down the leak source. He may need to conduct further inspections with the machine down, but the lube system still circulating the oil to pinpoint the leakage source. Of course, he would follow proper energy isolation and other safety precautions. At times, Eric may need a partner to help spot a leak in one place while he traces it to its source. Typical areas that may cause leaks are pipes, tubing, or hoses rubbing against each other or other equipment, abrasions or impact from surrounding equipment or environment, plugged oil drains, excessive oil flow to the equipment, high vibration or equipment lube oil or hydraulic surges, which may lead to broken lube or hydraulic lines or to loosening of line connections or fittings, excessively dirty oil that may erode seals, piping, or tubing or lead to deposits in lube lines, high oil temperatures from potentially poor cooling or oil flow that may over time deteriorate gaskets and seals, cold startup conditions. Eric estimates the observed leakage rate using tools like the oil lost from leakage table in the SOP, the standard operating procedure. To aid his customer to fix the leak, using root cause analysis, Eric may provide recommendations like these. Use enhanced lube line hangers that better separate the lines apart from each other or from surrounding equipment. These could absorb vibration and prevent leaks from rubbing. For hydraulic systems with hose or line bursts, working with the equipment OEM, he may recommend a hydraulic accumulator to reduce pressure surges. Use sheaths or protective covers that may be periodically inspected to prevent the actual oil or lube lines from deteriorating from rubbing or being struck by other equipment. Use high-velocity flushing with mechanical and or chemical cleaning to clear up plugged or partially blocked oil return lines. Optimize oil feed and flow rates to ensure the equipment is not receiving more oil than needed. Optimize lube system startup procedures to properly warm up the oil, to prevent return line backups or overloading of lube system pump motors. Upgrade oil meters, seals, or gaskets to provide better leakage resistance. To their surprise, Eric and Jeff run into a pretty obvious leak. No UV light required to see this one. Jeff quickly calls in a maintenance crew to tighten the loose connection and to clean up the pool on the floor. Eric also works with the plant personnel to understand the root cause of this leak to prevent it in the future. After his site visit and leak inspection, Eric will go over his findings, including measurements and photos, to prepare an engineering service report for Jeff and his supervisors. He must take in all the facts and sequence of events to determine the potential root causes. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce the best value. In addition to determining the reduced costs by correcting a leak, Eric also works with his customer to estimate the cost to make the leak repairs. He uses this information to determine the total cost of ownership, as well as to help the customer prioritize which leaks to correct first. Here you see part of Eric's leakage inspection check sheet that he would place in the appendix of his engineering service report. This information provides the details of each of his findings. Eric can demonstrate that his findings and recommendations produce an excellent return on investment and value to his customer. Eric and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. In addition to helping this customer in this one application, Eric will look to see how he can help the customer apply what they have learned to other similar machines at this facility or across their entire company. By using the standard operating procedure as a guide, as well as the other tools described, Eric can consistently conduct these inspections and deliver outstanding value to his customer.